Hello, Dr. Alex. Can you hear me?
Yep, I could hear you.
Okay, cool. Thank you so much for joining us.
Yeah, of
We'll
course.
start as slated, and I know it's night over there. Thank you so much.
No.
I think on behalf of all the students here, we are very much grateful that you spared probably the most important part of your day towards this. Thank you so much.
No worries. Happy to do it.
Yeah, thank you. So we'll start 1 p.m. sharp. That's in another 3 minutes.
Okay.
Yeah.
Sounds good. Let's see here. I'm just arranging my screens. I will, let's see here. I think present that one. Should just be the title slide.
Perfect.
Okay, good. So all of you, I see it clicked over to the top of the hour. Would you like me to begin?
Yes.
All right.
Traditionally, if you don't mind, I'll just read over your about me.
Okay.
Okay. So, good afternoon, everyone. My name is Aliu Kasim. I'm the host for this 2023 International Student Summer Seminar. Our guest today is Dr. Alex. He earned his PhD in chemical engineering from Purdue University. He focused on polymer composites manufacturing for low-cost, high-volume applications. He's currently the program manager for academics at the Hexagon Manufacturing Intelligence. In his talk, Dr. Alex will today discuss the ups and downs of graduate school and how his perspective on his graduate studies shifted throughout the years. Additionally, he'll share what's made him a more efficient researcher and the habits he wished he would have started sooner. Thank you so much, Dr. Alex. You can begin now.
I appreciate the kind introductions, LU. So yes, it's exactly what I'm here for. The title of the talk, Things I Wish I Knew When Starting My PhD. And let's just get into it. So along the way, I want you to think a little bit about how do you manage your time? How do you use how do you reference literature? How do you use citation managers? Like, are these things that you're currently doing? This might sound kind of basic, but how do you read a scientific article? You know, do you just start from the beginning and read all the way through to the end? Do you kind of skip around? How just think to yourself, how do you read the scientific literature? And this is a tricky, but how do you know what's important? Both like identifying gaps in the literature as well as um, when you're doing studies, like when do you realize that something is novel or not, right? Um, and how do you write a paper? Uh, for myself in particular, I found it to be a rather challenging venture. And kind of going back to knowing what's important, how do you know when it's time to publish? And so just let's keep kind of these thoughts and questions in the back of your heads and see kind of how I learned to answer those questions at the various years of my degree, and maybe you can kind of be a little bit quicker with it, right? And before I kind of move on, I do want to mention this one thing, and that is my PhD advisor always referred to knowledge as a T-chart, and that you should be very, very knowledgeable in your field. You should be the expert in your field when it comes time to defend, and the work that you are presenting, you should be the most confident one in the room. But just as important through the PhD is what knowledge you can learn that is adjacent to your field. Maybe it's not your specific topic, but it's the topic that your research group in particular works on. And it's important that you have a general grasp of what your lab mates, what your peers are working on as well, and perhaps in your department. Because even though you are going to study extraordinarily hard in this area and focus very hard here, you might not get a job specifically in what you researched. It might be in one of these adjacent fields. And so it's very important to always keep your mind open and always learning from others along the way. Now, this is my favorite chart to describe my experience as a PhD student. First of all, it took me 5 years. I went from a bachelor's and straight into the PhD, but it took me 5 years. And this productivity confidence by year so this little line here is kind of giving an indication of how happy I was, how confident I was, how productive I felt during the PhD. And if you zoom in, what you realize is that every week there's ups and downs. You are going to put together an experiment, run a model on your computer, and it's going to work. And you're going to be so excited because it works. And then you're going to do it again and realize that it doesn't quite work the way that you first thought. And so now there's some issues. Or maybe there was a supply issue. And so you aren't able to get your material on time. Or it arrives, and now you get to start doing your work. You get the software installed that you need, things like that. So just know that while there are these kind of global trends of, excitement and happiness, and it kind of dips down before it comes back up again, there are also these like day-to-day challenges or week-to-week challenges. And so don't let that disparage you. Just, recognize that that can happen, so you're better prepared for it. And in general, the way that I would describe my first year of grad school is that I took a lot of courses and I was learning lab techniques. There was a lot of optimism in the air, a lot of nervous excitement, really wanting to get in the lab and, get out of the classroom. And then in year two, heck, I got into the lab for sure. I was able to identify my research topic that was agreed upon with my professor, and I was beginning to collect data. I was beginning to perform these experiments, which was exciting. I felt I was being more productive. I was learning how to handle the lab. I was learning proper lab techniques. I felt productive. And then year three hit, and nothing was working. I was getting contradictory results. I wasn't able to get statistically significant results. And now I'm over here, nothing, like every time I try something, I try and repeat something, it's just not coming through. And so now I feel like I've wasted all of my first this year two with nothing to show for it. And it's a terrible feeling because I felt I had all of this time, but now the time it feels like it's slipping away. Um, and then in year four, I really, it just felt like things started clicking. I was starting to do experiments that were meaningful, that were reproducible. I was getting statistically significant results. I was starting to write papers. And then of course COVID hit, and so there's a little bit of like a lull, as everyone else, in the world experienced. Before really taking off, wrapping up my projects, writing papers, defending, and finally getting over the hump of it all. And so what I want to do is kind of dive a little bit more into like what was happening in each of these years and kind of, extract some of the things that I learned, as well as some of the things that I wish I would have learned or valued sooner, to be a little bit more efficient with my time. And then in terms of like output, the things that you kind of need to do along the way to kind of earn the degree. I attended a conference my second year, two of them in my third year, and even with those two conference attendances, I was down in the dumps. Year four, I got a paper out. Year five, there were two more papers. So you're really starting to output there. Um, and so, yeah, getting kind of going back to year one, it was all about this excitement and optimism, right? I was going from being a bachelor's student, being so used to taking courses, knowing that there was an answer in a textbook somewhere, to jumping into this research front. And so I selected my PhD advisor, research group. And I should mention that I ended up selecting a group that was brand new. So year one, I was the most senior student in the group. Didn't exactly know what I was doing, but I began reading papers. I was looking at Google Scholar, Scopus, Web of Science, ProQuest, all sorts of different engineering databases that you can search for the scientific literature. And along the way with reading those papers, I was, getting up to speed on lab techniques. And so for myself, I was more of an experimentalist, but for the computational groups, getting up to speed on how to navigate the software of choice for your group. And I was brought on to my first project. And so I was working on that. I felt like I had a goal that I was pushing towards. And some of the things that I learned in that first year, this might be totally obvious, but key words for my field, I realized I didn't know them. I was handed a paper by my PhD advisor, and he said, I want to go in this direction. And so, I read the paper, I read all the references, and I followed those keywords. But you also talk to your lab mates, you talk to your advisor, you find out what other keywords they're using and what they find value in, and then you try those as well. Um, and then sometimes there's recommended papers, or there's papers that are being published from your lab. Like my lab was new, but your lab might be well established. And so looking at some of the recent output from your lab can be very insightful, especially if they're still at the lab, then you can learn from them. Um, and something that I didn't fully believe, but if you actually go to these different databases and use the exact same search criteria, you will get a different list of results. Sometimes there will be more or less results depending on how narrow your search is. And it will prioritize them in a different order. And so it's very, very valuable to um, uh, make sure you don't just default to one search engine, but you actually go to a few different databases and make sure that you're not missing a piece of it, like a certain work or a certain article that is out there, because you have a great idea and you might read it a month later, 2 months later, and you realize that it's already out there. That's what I'm talking about when there's like this week to week kind of ups and downs. You have a great idea, you look into it more, and then you realize that someone 8 years ago, 10 years ago, already did it, which can be a little deflating. Um, and speaking of papers and reading those papers, I was taught that there's a certain way that you go about reading papers once you're familiar with the field. And that is you read the abstract first. You want to decide if you even want to download that paper. And if that abstract contains potentially interesting techniques, results, materials that you're working with, then let's say you download it. The next thing that I was taught is that you read the conclusions. You want to find out what the author felt was the most impactful piece of their work in that paper. And they're going to put that in the conclusions for you. And so you read that. And if those conclusions of that work are indeed in align with your interest or your reason for downloading that paper in the first place, then you go to the figures. The figures are the data. You want to see if those data, if the experimental trends, if those computational models showed the trends you were expecting, if they deviated, if it was a trend that you didn't know about and you wanted to see what that trend looks like, then that's where you're going to see it. Pictures are worth 1,000 words. But if it can be a confusing figure or something of that nature, then the next step is to go and look at the discussion in the body around those figures. And if you're still satisfied and you're quite intrigued by their work, you might want to read their methods section to learn how in the world they did it, because maybe you don't trust how they did it and you have concerns over the technique used, or you want to reproduce it for yourself. And so it's incredibly valuable to read the methods and learn how to set it up for yourself. And finally, the introduction, as odd as it sounds, is usually read last. Oftentimes, they're very similar if you're in the same field. They're going to give similar background information on that field, as well as some maybe more like niche applications for their specific work. And then the last paragraph in the introduction is really intended to tell the reader what's going to be worked on or researched or novel in the paper and the work, as well as what the novel questions are being answered, what gaps in the literature are being addressed by the work. And that's what you should expect out of that last paragraph in the introduction. And so that can also be a helpful one to read, just to give an idea of where this piece of work fits in to the greater field. Now, year two. And you can see over here, I kind of put a little red dot kind of showing you where I'm at in the ups and downs of grad school. And so I was continuing to do experiments. I was continuing to read papers. I was passing my departmental, tests, exams, things like that. And something that is the first lesson learned that you should really take away from this is that I had finished collecting data on my first project, and that was, finished up sometime in year two. And I did not get around to writing this paper until year four. And there were a few reasons that I'll get into, but just know that collecting the data and then publishing that work 2 years later, very difficult to remember everything that went on. You have to go through everything. Very inefficient with your time. And I should say that, again, I identified a research area of interest. It was for myself, it was high throughput composites manufacturing in low cost environments. And in that year too, I completed my first project and I wrote the report. And I was rather excited about that. I felt like I had accomplished something. I had wrapped a bow on it and I finished the work. And in the back, there were a few contradictory results on some side projects and things like that. But it wasn't anything that made me question the integrity of the report or ultimately the data that was published in that paper. Looking forward now. But there were some contradictory things that I needed to figure out. I still had time to figure it out because I was only over here, but I knew that I had to figure it out at some point. And another highlight was that I actually was able to design some manufacturing equipment and I placed that order. So I had equipment coming for upcoming projects that I was going to be able to use for my PhD, which was very exciting. And one of the first things that I will say is that I did not use a citation manager, or I did not effectively use one. I initially started with EndNote, and my other lab mates and things like that started using Mendeley. So I was kind of left behind, and I was sorting a lot of my papers just using the folder system on my computer, which I found out later on either I was not doing a good job of managing those folders, or it just created a lot of difficulty when trying to cite those works. Um, and so I really wish I had started some good habits at this point, like writing the methods section when I collected the data. If I had written that methods section when I collected the data, it could have saved me a week. Going through my old notes, making sure that I got everything for the various tests that I conducted, it would have been a huge help. Similarly, I wished I would have downloaded a journal template before actually submitting that paper, submitting that report. I wish I would have been writing things in the style, in the template of one of the journals that I would ultimately be publishing it, because I had to redo the formatting on things. And if you're using Microsoft Word, formatting can be kind of tricky and time intensive. And so that was another time waster for me. Which in grad school, you feel like you have all the time in the world that you can, spend, but you really try and value your time. Really invest in a good citation management system early on. And if you haven't done so yet, spend some time, get that citation manager organized and up to speed. It is so valuable. And I'll talk a little bit more about the different ones and like the one I now prefer in a little bit. During year one, I was able to maintain reading a paper a week, no problem, because I was trying to digest so much of the scientific literature for my field. So I was trying to read a lot and learn what the field was. Um, but once I established myself and felt I understood what was going on in the field, I would really only grab a paper here or there when there was something new that I was interested in, and I would be very selective with what I was reading. But what I really should have been doing is trying to select a paper roughly in my field, not necessarily my direct field, but adjacent, and just read a paper once a week. Regardless of the direct relevance to the project I was working on, it would have really helped keep my broad knowledge of the field up to date. And it's something that I wish I would have done sooner. And again, when you are downloading papers, keep them organized, take notes on them. I cannot stress enough that when you are going to write your paper and you just have a collection of PDFs downloaded, if they're not organized in some meaningful way to you, it will be very difficult for you to figure out which papers you want to cite in that paper. Again, think about it. I collected this data in year two. I read the papers probably mostly in year one. And then in year four was when I was going and trying to reference those papers and talk about how I did the work. And so something for yourself is just think, how many papers do you read in a week? How many papers do you read in a month or in a year? Just think about that. And also how you are managing your citations or the papers that you've read, or do you? My understanding is that there's three major citation managers out there. One is EndNote. It's owned by Clarivate, which is like the Web of Science platform. And then there's Mendeley, which has been produced by Elsevier, so one of the journals, publishers, I guess. Yeah, publishers. And then Zotero, which is more of an open source platform. I believe all of these are free. You have to double check, but at least as a student, I remember them being free. Um, and I started off with EndNote, and I can't remember exactly what the issues I had with it, but I ended up having some difficulty with it. And so I switched over to Mendeley when I realized that my lab mates were using Mendeley, and I would rather be able to collaborate with my lab mates. It's easier to do so if you use the same citation manager. Um, and all of these citation managers, they have fairly similar features. Some things that I really liked about Mendeley is that you can download a PDF and drop it into Mendeley, and it will automatically extract information from that PDF, like the author, publisher, journal, title, abstract, and put that into your database. And then, of course, you can edit it as you need to. It has a built-in PDF viewer. So you can also go in and take notes on the PDF itself, highlight certain sections, tag certain features, assign certain keywords to it so that it's easier to search for later. Because once you have all of these, say you have 100, 200 papers in your Mendeley, then you're able to search within that and either search by author, search through the titles, abstracts, or even the PDF body itself, or your notes to find that paper again much more easily. And furthermore, they have a built-in folder system. So you can, of course, move or make a copy essentially of all of the papers that are going to be relevant for your first paper, your conference paper coming up, things like that. So you're able to make sure that you reference all of the work that you had read previously. That kind of helped build your understanding of the field and what was relevant for that work. Let's see here. Yeah, so year three, that was the one that people are probably going to be interested in because all of a sudden the floor gave out, nothing seemed good. The way that I looked at this year was that nothing worked, and I felt like I just didn't have any time to figure it out, get things going. I felt like I still needed to publish 3 papers, and I felt like, there was no end in sight. Even though there was also no time left, kind of this odd dynamic going on in my head. Um, and so the first issue was that the first high or the last high that I had in year 2 became an overwhelming bummer for me. My equipment was delayed over a year. And when it arrived, I ended up having additional delays installing the equipment. And so that put a huge damper on projects that I had coming up. It influenced some of the conference papers that I was planning on writing, and then had to pivot a little bit. And again, I went to 2 conferences. I was very excited. My talks were well attended. People were asking very insightful questions, things that I wasn't expecting. I honestly didn't think anyone would care about my work, but it was a bright spot knowing that people had a genuine interest in what I was working on. But again, I was still having some lab experiment issues where things weren't reproducible. And also I was getting some lab results that they were reproducible, but they were totally illogical to what I had read in the literature. And I assumed certain things that the literature had to be correct in this way. And you'll see later on that I actually kind of stumbled upon something. It was actually a novel discovery, but I didn't realize it right away. And something that happened in my 3rd year is that new students joined the lab for the first time. So I was in my same cohort. No one was older than me, no one was younger than me. But now we had new students. And so with new students, we needed to mentor them. We needed to show them how we read papers, what citation managers we like to use, teach them on lab equipment, these kind of things. It's incredibly important to be able to share that knowledge, which I'll actually go into a little bit more depth here in a moment. But while I was going through this real downer of a year, um, there were certain things that I felt kind of helped pick me up at times. And one of those was having a few topics to kind of bounce back and forth with. Like I was juggling three different kind of projects that you could say. And so when one wasn't working, like the equipment being delayed, I would then pour more of my time into a different project. When that one had some, illogical things going on or not reproducible, then I would switch to the other one, give my mind a little bit of a break on that thought process and go with another one. And so keeping, hold of some of those projects that you maybe felt more passionate about, keeping those going can really kind of lift you up. And something else that was really helpful is that during group meetings, as well as outside of group meetings, I would learn what about the projects of others, within my group, and build a little bit more of an understanding of what they're doing. In some cases, they would have the problems of their own, and we would explain the problem and vent our frustration about the problem, and we would learn. We would get, advice from each other. I would offer advice, they would give me advice. Sometimes it panned out, sometimes it didn't, but at least it was an idea for you to give a try. And so you might leave the day excited, hopeful that you're going to give that a shot. And so it's really important to kind of find uh, what is it? Find inspiration from various sources. And something also, this might be quite relevant, is that sometimes it's better to stop while you're behind. Some of these lab experiments, I was working more than 12 hours in the day. And the answer, if you're already hitting a brick wall, the answer is not going to come to you after 12 hours or after 16 hours. It's better just to go home, take a nap, get some sleep, and come back the next day, assuming you don't have any deadlines that you have to meet for that project. And never lose track of your hobbies. If it's video games, if it's working out, running, um, going to restaurants, whatever it may be, cooking. Um, Keep your hobbies. They will keep you sane. So value your hobbies. And something that was also very useful for me is that when we had those new students come in, we did something like a journal club where everyone would read the same paper, and one person would present what they felt was the most meaningful results from that piece of work. And it's really insightful because you can compare how you thought and perceived that paper with the person presenting. And sometimes you get like a new perspective and see what's valuable or what other people are valuing. And you get a deeper appreciation for that work, that journal article that you read. And that's kind of comes in with the mentoring of the new students. Oh, excuse me. And speaking of mentoring students, the new students like that you are likely having in your groups, is that what it's really about is sharing the knowledge that came to you outside of the classroom. They weren't really taught in the classroom, right? Like lab techniques that are specific to your group. Likely you didn't learn those in the classroom, you learned them from another grad student or a postdoc or a scientist in your group. Um, Likewise, you probably didn't figure out how to read a paper right away. One of the best things that got our new students up to speed the quickest were the journal clubs where everyone was reading the same paper, and then one person presented. They had to put their thoughts out there, and then other people added to that, and so that helped them expand their horizons. And it gets them up to speed quicker so that they can be more efficient as well as they go through grad school. And this would be for some of the more seniors members of the group. But when you're writing papers and things like that, absolutely, include your lab mates in the paper writing process. Share drafts. Get your lab mates' feedback on papers. It both helps their writing because they can see what a senior member is writing and how they're writing. They can also offer feedback on either grammar, if there's coherency issues, um, and things like that. So it's incredibly valuable for both you and the person actually doing the reviewing in your group. And how to write a conference paper. They're a little bit different from journal papers. Well, first of all, when you're submitting an abstract, oftentimes those are just mini proposals, since I would say 9 times out of 10, when you write the abstract for a conference, the work isn't usually done yet. And so you're still kind of guessing a little bit as to what that may look like. And oftentimes a conference paper is um, an incomplete or a subset of a greater topic that would go into a journal article. And so understanding that there's maybe uh, the conference papers are less expansive, and so they have slightly different expectations attached with them. Whereas how to write a journal paper, which we'll talk a little bit more about that in a bit, so I won't dwell on that for too long. But if there's one thing that you should take away from this is that when you are teaching others, you are reinforcing those same skills for yourself as well. So it's a win-win. Yeah, so in year 4, after all of the negativity that was year 3, everything just started clicking. And the one thing that was in the back of my head was, do I have enough time like to get this all finished? My equipment was operational. I was nonstop in the lab collecting data. I wrote my first journal paper. Again, it was data from years 1 and 2, but I wrote it. It took me a bit longer to remind myself what I did, those couple of years ago, but I did it. And I even was able to propose kind of my own research topic that was identified as potential gaps from previous projects that I worked on, which was also quite exciting. And while everything was clicking and things were starting to really move forward, COVID locked out of the lab I think we were locked out for 4 months. And, I already had all of this momentum. I couldn't let it just slip away. And so I actually pivoted. I went from an experimentalist to a computational person. And so it actually ended up working out for me, as you'll learn in a bit, but I ended up getting my first job because of that additional computational skills that I picked up. Even though it wasn't my main focus of the overall PhD, it played an important role in my career. And while I was home with COVID, or not with COVID, but because of COVID, we weren't allowed in the lab. Year 3 data, I looked at it again and I realized it wasn't nonsense. I realized that there was the fundamental equation that I was using, the analytical equation that I was using. I realized that if it was just given a correction factor relatable to the material that I was working on, the weird part of the material, I realized that I would be able to adapt that equation and describe what I had observed. And when you put in for like that same, correction factor, you would return, like for a normal kind of material system, you would return back the original analytical form. And so it was, totally, it could go back and forth between the two. It was just a more comprehensive form of the equation. And so things that I realized in year 4 were that when I was working with those new students, I realized I knew more than I realized. As funny as that sounds, you don't realize it until you start to share and mentor another student. I also learned to never say never. I told myself that I would never be a computational person, and I told myself I would never do fluid dynamics or fluid mechanics. And the computational bit that I picked up was computational fluid dynamics. I'm glad that I did, but if you had asked me a year prior, I would have said no, absolutely not. Um, And looking back at that year 3 data that was nonsensical, or at least I thought it was, is that you got to check your assumptions. I realized that if there was just a correction factor to the original equation, especially one where you return back to the original form, um, then it's that assumption wasn't totally valid. And I had kind of wasted, I was down in the dumps in year 3, and I realized that it was just an assumption that I made that was wrong. And year 4, I was writing that first paper, and writing papers takes time. I'm not the fastest at it. But asking for feedback from my lab mates was incredibly helpful. It really sped up the process. And also, this is actually when I switched to Mendeley. So I actually switched citation managers here. And it is incredibly hard when you are trying to migrate over 200 papers that you've kind of stored in random places. And, sometimes you printed off your note or printed off the paper and took notes there. Sometimes you did them in a PDF. It just made it very messy. And then it was really difficult to try and collect which paper or which citations were going to which paper and things like that. So if you just pick a citation manager and always download a paper, put it in there, and then make sure it like cites correctly, you will save yourself so much time when it comes to the writing phase of your grad school, whether it's master's or PhD. And so some of the lessons learned from writing my first paper, the pre-writing phase. For the first paper, it's so important to identify a target journal that you are interested in publishing in. It doesn't need to be the one that you end up publishing in, but having one in mind is so helpful. Download their paper template. They should have a template out there that has fonts, spacing, margins, how to set up your sections and things like that in the way that the journal wants them set up. Incredibly useful. It'll save you time, especially if you write anything for anything else. You can always just grab that work and then start putting it into that template or into that paper. And you're already, moving along. You don't have to mess around with different formats, different fonts. It's just all in the same format. And read the publishing guidelines. There is going to be different papers or different journals, sorry, will have different guidelines on tenses, how to reference certain figures, page length. There's a lot of handy stuff to figure out for the first time by reading one of those author guides or publishing guides. Now, that's just like the pre-writing phase. It's just to build a good foundation for when you actually get to writing. And you should always put an outline out there for what you want to write and say. And what I realized for myself, and this might be a similar case for you as well, is that what really, really helped me was not actually making just an outline with, like a few bullet points and things like that, but actually making all of the figures that you are going to present in your paper and put those into a PowerPoint presentation. And then don't really, maybe put it like the section title or like the figure title like on the slide, but otherwise leave the slide blank and just present the figures. And if you can present a coherent story across those figures, then you're ready to start writing. And if, present those to your lab mates. And if you realize that there is like a sticking point in the presentation, then then add a figure, or look back and see what is missing about it to make that nice smooth flow. And once you have that nice, smooth, coherent story, that's when you really should start to open up your word processor, open up Overleaf, and start writing. And the methods section is almost always the easiest section to write because all it is saying, what did you actually do? What were the settings on your computer? What were the settings on the equipment? How was it conducted? So write that first, it should be the most fresh thing. And then start writing the discussion around your figures. And as you're doing that, maybe once it's done, maybe midway through, start putting in, writing your conclusions, because those should be obvious, right, from the work. And so you can start to form your conclusions. And once you're forming those conclusions and you have pretty good coverage in the discussion, conclusions, frame your introduction. Frame why the work that you did was so important. Show the gaps in the literature. Introduce the topic to the reader and why they should care about that field. And in that final paragraph of the introduction, tell the reader specifically what gaps you're covering, what questions you're addressing, and maybe a little something of like techniques used to address those gaps. And then finally, get feedback from your fellow grad students before publishing. They're a very friendly audience. You'll both get something out of it. In year 5, gosh, it was sprinting became normal, became comfortable. I don't know how to describe it, but everything just clicked. Everything was going smoothly. For myself, I had finished writing my final project report. I finalized data collection, which, looking back on it, I always felt that I was like 1 month away, 2 months away, 3 months away from graduating. And I was really more like 9 or 10 months away from graduating. And what you should really aim for is when you are done collecting data, 2, maybe 3 months after that, that is when you're going to be done, because you're going to be able to wrap up all of uh, you're going to be able to write all of your papers, put those into your dissertation. And so it usually takes like 2-ish months after you finish collecting data to pretty up that data and um, put it into written form. And for myself, I noticed that I was starting to shift my hours way earlier, or just really deviating it from when other people were in the office. Because for myself, I needed it to be so quiet when I was writing, and my advisor really wanted me in the office. And so my compromise was that I was going to be there during odd hours so that that my lab mates wouldn't bother me so much. Because once you've spent that much time studying the field, researching the field, using the lab equipment, your lab mates that are newer, they're going to ask you questions when they're stuck, right? You've probably been there because you've gone through this whole roller coaster. And so you likely have the answer, and they know you likely have the answer. And so they're going to ask, which is totally fair, but it can sometimes break the flow, especially for myself with writing. Um, and I should mention that writing a paper and the dissertation, not the same thing. Um, the dissertation is going to be much more robust. It's going to contain much more of a comprehensive literature review, especially for that introduction chapter. Your chapters of your thesis or of your dissertation likely will resemble your papers, but there's going to be a much stronger narrative, from your thoughts, as well as talking and expanding upon your thoughts of the scientific method and like the methodical nature with which you went through it. So there's going to be additional commentary. And again, it's just a realization that, you do know more than you realize. And I should mention some of the unexpected opportunities from grad school. And it's the one where I was picking up computational work. It led to my first job, and my first job is at Hexagon. And so Hexagon, they did a lot of, or they do a lot of, they make a lot of simulation software and structures, multi-body dynamics, fluid mechanics, acoustics, materials, and so much more. And I joined Hexagon as a manufacturing solutions integration engineer, basically taking my knowledge of manufacturing processes, the hands-on stuff that I did in grad school, and digitizing those into this kind of software domain. Um, And I have all of that I have to thank for is writing this paper on permeability simulation of weirdly shaped carbon fibers. And that's kind of what triggered all this. So you never know, what a certain project might lead to, is what I'm trying to say. And finally, just looking at the lessons learned, how to manage your time. If the deadline is not tomorrow, try again when you're fresh. If you're burnt out, you're not going to make the scientific breakthrough. Um, Never forget about your hobbies. Enjoy them. They're what's going to keep you sane. They really are. And having a couple of areas of active interest that you can kind of bounce between is so helpful when you get setbacks. It's so helpful to maintain the mental kind of fortitude. And, how to read papers. Learn what was happening in the conclusion, then look at the data, then learn how they did it, right? That's the kind of methodology that was being applied and that I was being taught on how to read those papers. And gosh, please be organized when reading those papers. File them into a citation manager. I liked Mendeley, but again, if your lab uses something else, just please file it away in that thing. It'll save you so much time. It'll save you weeks, if not months of time. Um, and I'm assuming you guys use some form of a citation manager, but if you don't, one of the reasons why they're really nice is that you can have a plugin in Word or LaTeX, and it will, when you insert a citation, in in a paragraph, it'll automatically format it to the citation format you're using, and you can just drag and drop and change those very easily. And then it'll automatically generate a bibliography at the end for you for your works cited. And when you're doing those literature reviews, especially when you're reading lots of papers, mark the papers that you want to cite in a future paper. The ones that you think are, man, that's a good one. That is one that I'm going to lean on and say, yes, this is a piece of work that I want to, call out in a future paper of mine. Start to mark those and try and file them away accordingly. And maybe I didn't touch on this enough, but knowing when to publish. Well, first of all, you need to finish collecting data. You need to create all of the figures you're going to need, and then start writing. But even then, get input from your lab mates. If you regularly talk about your work, then they can offer more direct feedback. They're going to be more equipped to be able to say, hey, I really thought you were doing this. Your paper, is telling me a different story. Is that true? And they can, identify those. And knowing what's important. Mentoring lab mates reinforces your own understanding and really can kind of help refine to you what's important. And additionally, talking with other lab mates, being able to broaden your knowledge of your field, more generally speaking, is so important. It is really what will help land you a job down the road. And just be a good steward for science and your shared spaces. So, keep things tidy, right? Be respectful of others. And with that, that's what I've got. So here's my email address. If you ever want to stay in touch, I know we have some time for questions. And here's my LinkedIn if you want to stay in touch that way. So thanks.
Thank you. Thank you so much, Dr. Alex, for a wonderful, wonderful, wonderful presentation. So I'll see if students have any questions.
I do see one in the chat, actually.
Yes. Yeah, he
Can
says,
you
yes. Can
yeah,
you emphasize a bit more on the computational skills acquired during this time period?
Yes. So basically, the problem that I was facing is that I needed to do a flow study around irregularly shaped fibers to basically determine what the permeability is of this, semi-porous or this porous material. And being an experimentalist first, my approach was to essentially set up what I would envision the experiment to look like. and then just run it as a simulation. So all I was doing was applying a flow inlet and then basically allowing the CFD to determine a pressure drop across that. And then I use that information to determine a permeability. And so it was CFD that I was learning on the fly. I did not have like a lot of material to work off of because there weren't a lot of people in my lab doing that. But what I did have was the user's manual for that software. And actually, they had an examples section, and I found an example problem that was very not quite the same as what I was doing, but I was able to tweak it and learn from it to set up my own model. And at one point, I did actually, I got stuck. I wasn't sure how to proceed. And so I actually reached out to the support line for the company. And some engineer on the other end met with me and first of all, was very surprised that I actually had a set up and working model because I guess they're used to people just um, not able to like open the software correctly. I guess I don't know exactly what they're used to, but he just gave me some pointers, on like kind of like what mesh quality, what mesh health you need to have like a result that you can kind of trust. So yeah.
All right. Are there any other questions? You can raise your hand if you want to speak, or you can use the chat box to type your questions. Dr. Alex, I would like to actually ask a question. And the question is about like when you try to, we know that, for example, research is supposed to be reproducible, scientific research. So in my experience, you when trying to learn, and when you reach that confidence level where you want to see whether you're really capable, so you want to just pick up some paper and try to reproduce it. But I find that in most cases there is not enough information for you to be able to completely or accurately reproduce the work. So can you shed more light on that for a graduate student who is just starting out?
Yeah. So in those cases, what I would say, especially if it's outside of your lab, contact the authors. Contact the authors of the work, and 9 times out of 10, they will be excited and they would like to share a little bit more of what they did so that you can look to reproduce that as well. I will say that it's usually more common to try and reproduce work from your own lab just because you have the internal knowledge already there. But I would definitely reach out to the authors if that's the case. And if they don't answer for whatever reason, then I guess you can highlight that as a potential concern and maybe write a more robust method section when you go to publish.
Thank you. And then Franklin says, given your venture into CFD, will you emphasize programming knowledge to really excel at it? You can see the
So
question, right?
yes, I
Okay.
got it.
Okay.
Yes. I would absolutely say that being able to write macros or scripts to interface with your CFD model um, would expand your skills and make you very valuable to future employers. One, so in that regard, it's valuable to do that. Number two is that if you are running models overnight and they finish maybe say after 2 hours, but you're already in bed, but you could have ran 2 or 3 additional models every night, just if it was automatically doing so. If you're able to script your CFD model to queue several or to automatically generate a design of experiments by varying the inlet velocities, pressures, temperatures, whatever it may be, in an automated way, that can be very valuable to your time efficiency. So yes, it's definitely valuable. And then Rabia, can you share these slides? I missed your initial talk. Also, I'm in my third year of PhD and I need it for my motivation and progression. It's very good to read it to be more determined while doing research. Rabia, totally. Yes, I will share these with Aliyu. I believe this is also being recorded. Is that right, Aliyu?
Yes, it is. Yes, it is.
Okay. And I think you'll probably distribute the recording
Sure,
as well.
sure.
Okay, perfect. So yes, you'll definitely be covered. And I totally can appreciate the struggle of your third year. I know I definitely was down in the pits during my third year. Oh, and then Minkael, what is the approach you used when learning new knowledge and acquiring skills required for your field? Do you just go for specifics? Um, let's see here. When I first entered the field, I leaned heavily on my advisor's knowledge and the knowledge of the lab mates around me and the grad students around me. When it came to learning techniques, I was absolutely relying on the knowledge of others. I tried to learn from others as much as possible. Um, when I was reading the literature and identifying gaps, the thing that I was doing the most was reading the conclusions that someone came up with. And I was also reading their methods and how they got there. And I was observing between those conclusions and those methods. And I guess a little bit in the introduction, like the gap that they were addressing, to see if there was something else there, if there was additional, curiosity, so to speak, that maybe could be addressed. And something that can sometimes be quite a treasure trove, and actually my advisor was rather sensitive to this, is that some conference papers will have a future work section, or even some papers do. And really, that's in a way, that's the author's omission saying that the work is incomplete, the gaps have not been entirely filled, and these are where we would like to see additional work be done. So that's an incredibly useful area. Another one is reading review papers. Review papers will often summarize the field in a very succinct way, um, sometimes spanning several hundred pieces of work, and they can kind of help identify gaps for you. They're very, very useful in that way. And actually, I should mention that I did read a lot of review papers, and I valued those a lot. It also helped me find other pieces of work that I would be interested in reading.
Thank you. And then probably last question. Will you please like what is novel and what looks like it's novel but it's actually not?
Oh, so how to tell if something's novel or not? Um, the first thing is start to tell others, tell your peers, present it at group meeting, talk to your professor, and they will either say that's absolutely nonsense. You clearly just forgot to turn on a certain setting in the machine. There's no trend that looks like this at all. You just have bad lab technique. That could be the case. I've definitely produced things that were bad. You're right. I was learning as well along the way. And so you'll get some feedback, from the group. And if it's novel, you have to be able to explain why it's novel. You have to be able to give an explanation. It's not just enough to say, I did an experiment and I can't find anyone else that has a graph that looks like mine or a figure that looks like mine. You have to be able to explain it. You have to give it a story. And if you're able to do that, then you do have something novel. Oh, and I do see one last question that came in. How were you able to manage contradicting results from your initial experiments? I had to do a lot of I had to look back on my own lab techniques. And what I found that was the most useful for me was doing the same one experiment over and over and over again, not changing a single setting, not changing a single thing, just loading the machine, running it, collecting data, analyzing it. And I did that probably for a few weeks, honestly. And that was, at least in some instances, that was able to help me refine my lab technique and therefore refine some of the contradicting results that I was getting. So yeah, thank you again for all the questions. I really appreciate the activity.
Thank you, and I'm really mindful of the time where you are. So I don't know if there are no other questions. I would like to allow Dr. Alex to have his rest. What's the storytelling, and how is it usually structured when writing a paper?
Oh, sorry. Thank you.
This is probably the last question.
Okay.
Yeah.
What's the storytelling? Yes. So great question. So when I say like the data needs to tell a story, it needs to tell a few things. When I say the story, I now mean the paper. The paper needs to tell you, why is this important? So in my field, in the introduction, what's the relevant challenge? What is the challenge? What's the gap? And why is it an important gap, right? You could be asking all sorts of questions, but they might not be scientifically relevant. Additionally, they might have already been addressed. So you need to demonstrate that there's a lot of work out there and they've done a lot of great things, but they omitted something that you feel is quite important. And there's always gaps in the papers. When you go to write your paper, you feel that you just wish you could do one more experiment. You wish you could do one more thing. You wish you could add an extra material system, an extra test, whatever it may be. So just know that there are gaps out there, and that your story should first paint the scene, show that the gaps exist, and then you should show that you followed a scientifically valid method to produce statistically significant results that show that kind of fill in that gap, that start to close the knowledge front a little bit, that can explain some of the behaviors that you think exist, that you think are out there. For instance, when I was I'll talk a little bit more about mine, I guess. I had these really oddly shaped fibers, and I thought that they would induce some very strange effects when it came to compaction. And I thought that it was just going to be stiffer or less stiff, but they ended up being more stiff. And they also had, like, the curve was a really weird shape. And so I looked at it more, and I realized that there was a fundamental change in how that material was compacting. And because of that, it was creating this different curve. And so I was able to expand upon a well-known analytical equation to accommodate this edge case that actually had a commercial value as well. So I guess that's kind of the structure of the writing and telling that story.
Right.
And was there one more question?
Yeah, someone wanted to ask. Lowell, do you want to speak instead of writing, if the writing is taking time.
Okay.
Yeah,
Good
just talk.
Thank you very much for your for the great presentation. I'm going to ask about how do you manage like an experiment that's not actually matching with your expectations?
Yes. So the first thing I always ask myself is, what did I do wrong? You know,
Yes.
what,
Yeah, that's
absolutely. And sometimes it's not totally obvious what I did wrong. And I would go and tell a lab mate, and I'd say, "What the heck?" And maybe they've ran a similar experiment or did use the equipment for something else, and it could have been for a totally different reason. And they might say, "Hey, yeah, I experienced that as well. There's a smudge on the microscope." It could be something totally simple, totally out there, that you wouldn't even be thinking about because you assume the equipment is clean. It could be something like that. So talking to others that are also using the equipment can be very helpful. What else? If it is, not that, and you can reproduce that odd result, maybe start to consider what if it's unique, what if it's novel. And you're then going to go back to the literature. You're going to start to search for this very specific thing, and you're going to look really hard because you want to be absolutely confident that what you are seeing is unique and novel, and no one else has seen it, or at least no one else has published about it. And if that's the case, then all of a sudden your excitement for that result starts to creep up and starts to creep up. And if after a little bit you still can't find anything on it, and you've started to talk to professors and other experts in the field and they haven't seen anything on it, start writing. That's the time to start writing. You might have something there. So that's what I'd say.
Thank you. Thank you so much, Dr. Alex, for such a wonderful presentation. And I'm sure all the attendees and students like me enjoyed as much as I did. But I'm really mindful of the time over there in California, and I would like to really thank you so much. So in the absence of thank you, in the absence of any further questions, I would like to, on behalf of students, appreciate the time that you've put into this, and the efforts making the slides and everything.
Oh, it was
Putting
a
your
pleasure.
knowledge through in a way that all of us, literally all of us, can easily relate with. Thank you so much. Any final words?
No, you guys have been fantastic. I appreciate the questions, and I'll share the slides with all of you
Right.
probably tomorrow. I might go to
Right.
bed now.
All right. Thank you so much.
Yep.
All right.
Bye.
Bye. All right, everyone. This is we've just come to the end of today's session. Thank you very much, and this is the end. Bye bye.